Welcome back to the Cisco CCNP route training from TrainSignal. Again, my name is Joe Reinhardt and I'm your instructor. We're actually going to wrap up our consideration of EIGRP with troubleshooting. I realize that in the CCNP series of exams that the T-Shoot covers a lot in the troubleshooting realm, but I want to be able to concentrate a little bit more specifically on EIGRP itself, some of the peculiarities and things that you need to keep in mind. So it's going to be somewhat general, but it will cover the different aspects of EIGRP troubleshooting. So the first thing we'll do is look at a model for troubleshooting, just in general, some common issues with EIGRP and the resulting resolution steps, some relevant debug and show commands that you can use to be able to determine network issues, and then finally dealing with the Cisco Technical Assistance Center, or Cisco TAC. If you're doing anything with Cisco routing equipment, you will eventually have to deal with Cisco TAC, and understanding the rules of the road and how to best leverage that, I think, will be very helpful in your career as a network engineer. So let's begin with the troubleshooting model. One of the things that I have noticed in my years of experience is that those who just use the expression shoot from the hip and just try to figure things out on the fly can frequently become frustrated. And that's one of the reasons about having a tried and true troubleshooting methodology is critical to be able to have success as a network professional and to be effective in our respective jobs. The general model is to start, well, I'll show you a flow chart in a moment, but it's define the problem. You have to know what the problem is in order to be able to deal with it. When you have a user say something like, the network is slow, the first thing that's advisable to do is ask them what they mean by it's slow. Is their Facebook not coming up? Or are emails not coming in, or they're coming in very slow? What you may find in the question that you're asking to them is that they may be downloading an enormous file, and it's no wonder their network is slow because they're slowing down their particular network connection. That's just an example of making sure you actually understand and define what the problem is. Then gather the facts. Who does it affect? Does it affect a large group of people? Is it one person? Is it a specific group of people on a specific floor or out of a specific office? That's important to know. Gather the facts. Then document the facts. Make sure it's written down and on paper, and when possible, get people to confirm that. Consider the possibilities for the symptoms that are being described. Again, going back to the person downloading the file, it could be very easy to figure out that the reason why it's becoming very slow is because of what they're downloading. Or it could be they picked up a particular network problem or a computer virus, and that's affecting them, but it's not affecting anyone else. Then, once you've considered the possibilities to what the cause might be, create an action plan. Figure out what you're going to do, in what order, and how you'll be able to test that. Then implement the action plan. Once you've done that, ask yourself the question, did it work? Did it change anything? Did it make the problem worse? One of the things that's important about implementing the action plan is make sure you isolate what it is you're implementing. If you try to implement too many things at once, you can create more problems that you solve, or you won't even be able to figure out what actually solved the problem. And then, if it doesn't work, repeat until resolution happens, and when all is said and done, make sure you document everything in a way that's accessible to the other network engineers that are both working with you and may come along later as well. This is actually just a flow chart of the same type of process we were talking about. You can see that there may be several iterations of the process, but make sure you follow this type of process. It is critical to your success and can save you a lot of frustration. EIGRP is a very unique protocol, and as such has some unique situations and problems that are common to the protocol. So one of the things we want to do is to understand some of the common resolution steps for some of the common issues that come with the EIGRP protocol. And essentially there are three major groupings. There are neighbor relationship problems. There are problems related to routes missing from the IP routing table or topology table for EIGRP. And then a third common problem is address summarization issues. So one of the first things that you can run into in EIGRP is a problem with neighbors establishing relationships with one another. And there are a variety of different causes, and it's important to be able to look at these different causes and determine if maybe one of these is actually the cause of the particular issue you're dealing with. One of the first causes is mismatched K values. You may remember the metric weights that EIGRP uses for route calculation are bandwidth and delay by default, which is K1 and K3. It may be that for one reason or another something was misconfigured in the K values of the neighboring router, and that may be the issue. If you use the show IP protocols command on all of the affected devices, you will actually see the K values spelled out. Make sure they match. If they're not, you can go back into configuration mode, enter EIGRP router configuration mode, and use the metric weights command to be able to send the values back to the defaults. Remember, K1 and K3 are enabled by default and the rest are usually 0. Make sure those settings match and are correct. Make changes if it's required, and if indeed after that the neighbor relationships all come back up, you realize that's where the problem was. So that's one particular cause for neighbor relationships not forming. Another cause could be mismatched autonomous system number. In one of our labs, I had accidentally put EIGRP 10 rather than 100, and that created another routing process, and that's why the summary address I was putting in was not working correctly. Make sure that the autonomous system number matches on all of the routers. You can do show running configuration and look for that. You can also do show IP protocols to find the autonomous system number. And if the autonomous system number is incorrect, just delete that routing process and start it all over. If it's involving a production network and the device is already down, it's not going to affect anything, but always be careful when you have to make major changes. Another configuration issue could be misconfigured neighbor authentication. You've enacted neighbor authentication and there could be an issue. I know when I was first putting it in our lab, but just as a test, I had put in my EIGRP key with a space after it. Didn't even realize I put a space after it until I used the show key chain command. And then it showed my EIGRP space with quotes on the beginning and the end, and then I realized where the error had crept in. So execute that command, the show key chain command, to verify the key string is correct, and then also look at the send and accept lifetime settings. It could be that the key is invalid because it's already expired or some other things like that. And if need be, reconfigure the correct strings or send and receive values. Another way to be able to look at the neighbor authentication is do show running configuration and make sure that, and this is probably one of the most common causes, if you go underneath the interface configuration, look for the IP authentication keychain command. That has to be there, identifying the key. But more often than not, the IP authentication mode command may be missing. And if the mode command is missing, it's not going to work. So verify that. Looking at the configuration, it's very easy to add back in. So add it in and use the correct syntax if it happens to be missing. Another common cause for neighbor relationships not forming in EIGRP has to do with primary subnets. If you recall in our discussion earlier, when interfaces are configured, they have usually one IP and they can have a number of secondary IP addresses. The EIGRP relationship has to be put on interfaces sharing a common subnet. In fact, not on common subnet is the warning you will see if it is not configured that way. Make sure the primary interface of both links has the same IP subnet and it's primary on the interface. If it's not, it's easy to verify. Do show IP interface and you'll actually see the network and mask that's configured, and any secondary addresses are that as well. You can also do show running configuration and look as well. If it's not on the primary IP, then change it to that. So otherwise neighbor relationships will never form. Another cause, a little more far-fetched but still possible, for neighbor relationships not forming is that it's not receiving the hello packets. One thing that could happen is that it could be that multicast traffic is being blocked, in which case you can do the show IP interface and show access list commands to see if any filtering, specifically access list packet filtering, is blocking multicast address. For instance, if you do a deny from a certain segment and you have a permit statement and you forget about the implicit deny all at the end, you could inadvertently be filtering multicast out. So if that's the case, add in any necessary statements permitting both the EIGRP protocol and the 224.0.0.10 if necessary. Also, make sure the interface is up, that the physical interface is up and operating, and that the logical layer 2 protocol is functioning as well. If the interface is up, down, then neighbor relationships will not form either because it can't reach from a layer 3 perspective. If that's the case, replace the interface card if it's bad, replace the cable. It's shocking to me the number of times it's simply a cable that's gone bad. Or there may be, at extreme situations, you may need to replace the device. But make sure you always check those things as well. Another thing that can happen is that the neighbor relationships are not forming because of misconfigured network commands. It could be that a number's been transposed or a mask is incorrect. Do the show IP EIGRP interface first to verify that EIGRP is operating on the interface as you're expecting it to. That's usually pretty definitive. An alternative, or even in a second step, is to be able to do a show running configuration to verify that the network statements are correctly configured. If for some reason they're not, delete and recreate the statements with the correct subnet and mask combinations to identify the interface that's affected. So you've put your EIGRP network together, neighbors are peering with one another, the relationships have formed correctly, and that's all operating the way you expect, but then there are routes missing from the table that should actually be there. So what are some causes of that? Well, first, as we looked in our lab, it could be split horizon is in effect on a multi-point interface. Now let me just clarify. There are two types of multi-point interfaces, and this is specifically regarding serial interfaces. The natural interface, in other words, if you configure frame relay just on the physical interface, that is considered a multi-point interface. In addition, if you create a sub-interface using the multi-point command, it will also be considered a multi-point interface. That one's pretty much self-explanatory, but a lot of people don't realize the physical natural interface is also considered a multi-point interface. So do a show running configuration and look and confirm if the no split horizon with the correct autonomous system number has been configured. If it hasn't, make sure you go into either the natural configuration mode of the interface or the multi-point configuration mode and put it in there. If for some reason it's in there but the autonomous system number is incorrect, make sure that you take care of that. But split horizon will cause any number of issues with route propagation, as we saw in our lab. Another reason, and very common one, that routes may be missing from the IP routing table has to do with automatic network summarization. Even though there are wild claims that certain versions of iOS code have automatic network summarization disabled by default, more often than not it is enabled and causing the source of missing routes. So the first thing to do is show running configuration and look specifically if the no auto summary command is configured under EIGRP. If it's missing, it means that automatic summarization is in effect. You can actually also use the show IP protocols command and look for the specific statement automatic network summarization is or is not in effect. If it says it is in effect, it's a very quick fix. You go back in, you execute the no auto summary under EIGRP configuration mode, and away you go. But frequently this can be something that will cause problems with routes not propagating or displaying correctly. Another cause has to do with network statements being misconfigured under EIGRP. It could be that numbers have been transposed or the wrong subnet was put in place or the wildcard mask may be incorrect. But execute the show IP EIGRP interface to discover if the EIGRP interfaces have been identified correctly. Alternatively, you can do show running configuration and look at the network commands to make sure they're working correctly. And if they're incorrect, just delete and recreate them. It's usually easier to do that than some of the other alternatives. Make sure the mask and subnet combinations are correct. Another area that we can look at, aside from IP routes not appearing in the routing table and the neighbors not appearing as expected, is address summarization problems. And one of the reasons why address summarization may not work is because there are no subnets in the routing table within the range of the summary addresses. For instance, what we configured in our lab was a summary route for 10.2.2.0/24. And within the routing table of router 2 was the 10.2.2/32 network. Because that was present, the summary address would be propagated. If we went into that loopback interface and shut it down, the summary address would stop being advertised because there is no subnet in the table that's part of that range. So one of the ways to do that is do a show IP route command to see if any networks within the summarized range exist. You can also do show running configuration to verify that the IP summary address EIGRP statement is correctly configured on the interface. It's the correct network, it's the correct autonomous system number, and so forth. And if it's incorrect, delete it and recreate it. It's a quick way to take care of a summary address issue. When you have to face a problem with EIGRP not functioning correctly, it's important to know what commands you can use to actually assist you in determining causes. And so we want to actually take a look at the different show and debug commands that are available for the protocol. To begin with, show commands are your best friend when it comes to these sorts of things. You can first use the show IP protocols command. It will show all the routing protocols that are running on the router. In this case, you can look at EIGRP. You can verify the status of whether or not it's running, what the autonomous system number is, the K values that are configured, protocols being redistributed, networks being advertised, and whatever neighbors or gateways are present in the EIGRP process. It can help you with neighbor relationships, missing routes, summarization issues, and filtering problems rather soundly. Show IP route EIGRP actually displays the contents of the routing table specific to EIGRP rather than having to sort through the entire table. It'll show you the EIGRP routes from neighbors, the feasible distance metric, the route sources and interface, and administrative distance type of things. It can be helpful in determining missing routes, what is there, what should be there, summarization, filtering problems, and so forth. Show IP EIGRP interfaces is very helpful because it will actually specifically spell out both the neighbors on a particular interface and the interfaces participating in the routing protocol. You can easily look at that and determine if something's not correct. I have on many occasions when something's not been working used this particular command, discovered something was configured incorrectly with relation to interface configuration, and then taken care of it that way. So it can be very helpful both for neighbor relationships and routing protocol configuration issues. Show IP EIGRP neighbors actually goes a step further than the interfaces and actually identifies the active, fully adjacent neighbors, their IP address, their hold time, the autonomous system number, and the fact that they are fully functional. Great for troubleshooting neighbor relationships. There's even the Show IP EIGRP neighbors detail that can give you some additional information. Show IP EIGRP topology displays the contents of the EIGRP topology table. It's a complete listing of the database. It lists whether the routes are active or passive, the feasible distance, the reported distance, the successors and feasible successors, multiple routes, and so forth. It can help in troubleshooting missing routes, stuck and active, filtering problems, and general troubleshooting. In fact, the SIA status will actually give you a great concept of where things are in terms of the network in relation to anything that's stuck and active. Debug commands can be helpful as well, usually when you're troubleshooting things like neighbor relationships. You can use the debug EIGRP packet. You can look at hello packets, update packets, query and reply packets, acknowledgments, stub network packets, and it can deal with a whole host of issues. Routing updates, neighbors, stuck and active, stub routers, and so forth. Debug IP EIGRP can actually demonstrate and display whatever routing events are going on. Routing table events, EIGRP routing events, update processing, and can help troubleshoot a variety of those issues as well. So now that we've examined some of the debug and show commands, let's actually look at how that operates. We'll go to router 1 just because it has so much available. We go in, show IP protocols. Notice here it lists the autonomous system number, the process that's running. It talks about default networks being propagated. Our K values, notice K1 and K3 are configured. Variance, which is talking about our unequal cost load balancing. The networks being routed. And the other neighbors that are involved. Show IP EIGRP interfaces. Interfaces, peers, notice we have neighbors identified here. A lot of non-zero data here. Show IP EIGRP neighbors. A lot of detail. Show IP EIGRP topology. successors, feasible distance, reported distance. A lot of great information. Show IP route, EIGRP. A lot of information displayed there as well. So these are the kinds of things that can really help you in troubleshooting, as well as the strict IP EIGRP commands. There are the general ones, and then there's debugging commands as well. But these are your best friends in being able to isolate and take care of problems related to this protocol. No discussion of troubleshooting would be complete without outlining and understanding the whole process of dealing with Cisco TAC, namely the Cisco Technical Assistance Center. So I want to take a moment to be able to go through the process of understanding what TAC is about severity levels, a little bit about opening a TAC case, specifying information to have ready, how to work the case actively, and a little bit about TAC case etiquette. To begin with, you need to understand what Cisco TAC is. The Cisco Technical Assistance Center provides 24/7 by 365-day coverage for all Cisco product lines: routing and switching, security, unified communications, wireless, data center, and so forth. These centers are located worldwide, but there are several primary sites located in San Jose, California, Sydney, Australia, I've dealt with them a number of times, Raleigh, North Carolina, and Brussels, Belgium. One of the things about understanding with TAC is you have to deal with cases, and picture to the left is contact and support cases, how to open a case, how to review cases, looking at case status, updates, and so forth. But one of the things that you need in order to be able to get any kind of a case open is something called entitlement. In other words, you have to have a valid SmartNet, which is maintenance service contract. Gone are the days of simply being able to call up the Technical Assistance Center and just simply get assistance without any issues. Now you need to actually provide some proof of entitlement. In other words, that you have a valid service contract. Now a little bit about severity levels. There are several levels of severity. They all have different meanings, and it's important to understand what they mean with relation to TAC cases. The first is severity 1, or S1. This means that your network or environment is hard down, and there's a critical impact to your business operations. And you will commit whatever resources are necessary around the clock in order to be able to get the situation resolved. In addition, Cisco will pledge to do the same. Now, I want to interject right here to be very cautious in your use of S1 as a way of being able to get the case processed faster. Many times what will happen, even though you own the severity of the case, is it's very easy just to want to be able to make a severity 1 just so people, at the Cisco TAC will respond on a faster basis. But if it's not truly a network down emergency, then you're probably better off not using that, because it can just create all sorts of issues. You don't want to be the network engineer that cried wolf, so to speak. So use the escalation process for an S2 or S3 if it's not proceeding as you want to. So that's an understanding of severity 1. Severity 2 is the network operation is severely degraded. It's still operational, but it's degraded, and significant aspects of the business operation are negatively impacted by the lack of performance of the network. You and Cisco will commit full-time resources during normal business hours, 8 to 5, Monday through Friday, and so forth, to be able to resolve the situation. So it's still, there are problems, they need to be resolved quickly, but it's not as though the network is down. Severity 3 is network is impaired. The operational performance of your network is impaired, but most business operations proceed as usual. You and Cisco are willing to commit resources during normal business hours to be able to restore service to satisfactory levels. And finally, severity 4, which really isn't severity at all. It's simply that you require information or assistance with capabilities, installation, configuration. There's really no impact to business operations whatsoever. This is more of an inquiry. How do I configure EIGRP or a specific feature? This is more of the question there. There's no real impact on business operations. There are several methods by which you can open a TAC case. The first is by email. You could do it tac@cisco.com. On the web, you can go to the URL that's here. Obviously, pictured to the left is a way of being able to go to the support section of the cisco.com website and open a case. You can also open a request by phone, and these are the various phone numbers throughout the world US and Canada, Europe, New Zealand, Australia, Asia Pacific. There are a number of different pieces of information that are extremely helpful and in some cases critical to have when you're opening a Cisco Technical Assistance Center case. The first is what I would call must-have information, things that if you don't have it, it's going to slow things down dramatically. The first is your Cisco service contract number, and this specifically would be the SmartNet contract for the device you're calling about. If you have a Cisco Unified Communications problem and you're using something from your Cisco ASA firewall, it's not going to get you very far. So have the valid service contract number of the device you're calling about. Next, have the product or chassis serial number. On routers, you can actually get it from the command line. You can also find it on the device itself. Switches, something similar. There are a variety of places you can get the information, but know what that is. Also, understand the product model number and the hardware configuration. What type? Is it a 2811 router? Is it a 3560 switch? How is it configured? What's in it? What adapters and so forth? The physical location of the product, if it's in your core office, if it's in a remote location, if it's internationally located, all those are going to be important. And then, of course, the severity level, S1, 2, 3, or 4. Now, information that's very helpful to have, but not necessarily strictly required, is an accurate description of the issue, and usually some way of describing it with a title. That way you can use it for your case. Another would be a history of the problem. Is this a new problem? Is it a recurring problem? Is it intermittent? Being able to understand the history of it. How your network topology is set up, and explaining a little bit about the way equipment is deployed. Output from the show tech command, if it's applicable, and other relevant output, which you can actually attach using the case tool. Software versions and types of equipment. Relevant syslog or TACACS logs before the issue occurred, they can be helpful. So those are some pieces of information that can accelerate things just a little bit. The next thing you need to do is to make sure you work the case actively. Be sure from your side of things that you send updates and information as requested. Many times you'll get an email update that'll say things like Cisco pending or customer pending, something from the engineer. Usually there is a line called attach at cisco.com as part of the email string, which keeps everything in the system. But make sure you maintain regular communication, whether it be by phone, email, or whatnot. And then finally, when the issue's been resolved, make sure you close the case. Leaving it open for long periods of time is not usually helpful unless there's some reason why you think this situation might recur. But when the situation's resolved, make sure you close the case. Now, a little bit about etiquette when dealing with the TAC engineers. First, treat the network support engineer with courtesy and respect. I'm certain that all of us have had situations where we have been talked down to or not treated particularly well because someone was upset or angry or there was some big emergency going on. Realize that they are there to help you, but they are also people and network professionals just like you. Treat them with the dignity and respect that comes with a position like that. Also, realize that TAC is not a substitute for on-site staff. In other words, it's not an extension of your staff to be able to call TAC for a lot of problems. They are there to be able to assist, but that's not to say that there should still be adequate engineering skills and personnel available to be able to deal with problems. Create separate TAC cases for each issue unless clearly linked. If there's an issue related to LAN switching and there's an issue related to routing and another unified communications, those are 3 cases. Granted, they may interrelate, but the technology and expertise of the TAC engineer is going to be centered within the technology that you're dealing with. Keep that in mind. Also realize you have control over the severity level. If you think it's a severity 1, you ultimately have to make that call. Again, please use that sparingly, but when it comes to S2, 3, or 4, or S1, you make the call. If you feel like you're not getting treated correctly or you're not getting priority, make sure you escalate to the TAC duty manager, which you can certainly ask for, to move the case along. Occasionally, it may be necessary to do that, so don't be afraid to do that, but also, again, use it sparingly. And when things have gone well, when a situation has been resolved, pass your compliments on to the support engineer supervisor. I actually had a unified communications issue that I was dealing with a few months ago where the database had gotten corrupted and 2 of the subscribers were offline, and it was creating all sorts of network problems. It was slowing everything down. I opened a TAC case. This was on behalf of a customer. The TAC engineers actually said, there's something we want to try. It's not necessarily best practice, but it'll probably take care of the problem. I got the customer on the line. He agreed to it, and it cleared the problem up within minutes. And so that was one of those kinds of things that you really want to be able to give kudos to the supervisor for. So keep in mind that bad news usually travels faster than good news. So by all means, take the opportunity to pass good compliments along to the supervisor of the Cisco TAC engineer if they've done a particularly stellar job. So some terms you should know. Cisco TAC, the Cisco Technical Assistance Center, is used for Cisco products 24/7/365. It's essentially the help desk support system. S1 severity is a severity in which the production network is down and in a critical state and needing immediate resolution. S2 is the network is severely degraded as far as performance is concerned. S3, the network is up and it's running, but it's impaired though functional. And S4 is more of it's fully operational, but it's more of a configuration and assistance type of severity. So what have we covered? We covered the troubleshooting model, ways to be able to isolate and look at problems in a way that makes things simpler and more streamlined. Common EIGRP issues and resolution steps. Relevant debug and show commands, and we actually went into the devices to do that. And finally, dealing with Cisco TAC. Thank you for your attention as we went through EIGRP troubleshooting. We'll be continuing with more of our lessons very soon. Take care.